Hello everybody, and welcome to the first part for these lecture notes about 6.1, where we are talking about how to solve systems of equations by using matrices. And this is going to be one of the topics from the class that's definitely a new topic. Not this idea of solving systems of equations, because that's one of the very popular topics from even Algebra 1, but this idea of using matrices to do so. And so I don't want it to seem too complicated, it's really not, but I do want to just recall a couple of ideas about solving systems of equations in general. So we can have, thinking about in Algebra 1, you can have some kinds of systems of equations like this, and then you would be asked to find the solutions for this system. Now, there's a couple of things that we can do to try to solve it. We can use elimination, which is by adding and subtracting rows. You can also do things to these rows, like you can multiply an entire row by something. That's really the idea that we're going to be continuing with matrices, and we'll get to the terminology for how we describe those kinds of operations. But first, I just want to think about how would you convert this thing to a matrix. And the way that we will do it is we will make here something, it's going to be called actually an augmented matrix, because I'm going to put this dotted line here. This makes it become augmented rather than just being a normal matrix. But what we want to put inside of this matrix are the coefficients from this system. So there would be, and based on the way that I wrote it right now, it's not clear what the coefficients are for everything, but there would be a coefficient for x here, there will be a coefficient for y, and then in the second equation there's a coefficient for x, there's a coefficient for y. The point of the augmented matrix is that we will put these constants inside of the same matrix. Whatever is on the other side of this dotted line is what's on the other side of these equal signs. So the dotted line and the equal signs, they are basically representing the same thing. But this matrix we just want to make out of the coefficients. And so what is the coefficient for x in this one? Maybe it makes more clear if we write that this is 1 times x, this is 1 times y. And of course, whenever we go in the second equation, we go minus y, that's the same as like negative 1 times y. And so, or we could even think of it as being plus negative 1 times of y. That's how you get minus y in the first place. And so we're going to make a matrix out of these coefficients, and so we will put them, it will go 1, and then the one for y goes 1, and then because it's an augmented one, we will put the one that's on the other side of the equal sign there, and then we would take this 2 over here, that's the coefficient for x there. The coefficient for y in the second one is negative 1, and then the coefficient that's on the right, this kind of a constant coefficient, is just 2. And so there we've done it. We've converted this system of equations into basically a matrix form. And then when we go about to solve this system right now, what we're going to do are called elementary row operations. And these are going to be the familiar operations that we've done before whenever we're solving systems of equations. For example, one of the elementary row operations is that we can simply interchange two rows. And we would call the rows, for example, like row 1, row 2, and then we would interchange them. And if we did that for the matrix that we have here, of course, this row is row 1. This second row we're calling row 2. So if we just interchange those, then we would end up with one. We want to put the second row in the place of the first row, so we would have this 2, negative 1, and 2 in the first row, and then the second row would become our old first row. And then we will have a new matrix like this one. And in this case, it may or may not be necessary to do this operation, And we don't have to use every type of operation here. We're just trying to discuss what are the elementary row operations. And there are 3 of them. We saw that the first one is interchange 2 rows. There's another one that we are able to multiply any row that we want just by any constant that we want. Except for here, of course, you don't want to multiply a row by 0 because then the whole thing just becomes zeros. That's not going to be a good idea. But we can multiply by a constant, and in this case we would want to multiply by a non-zero constant. For that reason, we don't want the whole row just to become 0, then it's useless to us. And so, for example, we could do 2 times of row 1, and that can become the new row 1. It would be possible to do that. And so here, I'm not doing these operations, by the way, in a consecutive fashion, so forget that I ever, oh, and I meant to say here, interchange it with row 2. Sorry about that one. But here, I'm just going to continue based on the original matrix that we had up here. If we replace row 1 by 2 times of row 1, then we would just come in here and multiply all of these coefficients 1, 1, and 1. We would multiply them by 2, so it would have a new first row that would go 2, 2, 2, and then the second row would stay the same, 2, negative 1, and 2. And then this would be our new matrix. And then finally we have another elementary row operation, which is that we are able to, in this case, we will be using this word again because this is actually going to be the main method that we're going to have for solving these matrices. Is we're going to be using elimination. And always when you're doing elimination, we're interested in adding, and it's possible also to subtract rows, but we will basically simplify it by saying that we're able to adding, I will write it this way and then I will explain why I would want to write this one. Adding non-zero multiples of one row to another. And so probably could have just said multiple. It makes more sense to say multiple instead of multiples. Adding non-zero multiple of one row to another. And so we may, for example, want to say, how about if we added 2 times of row 1 plus row 2, and that will become our new row 2. We may like to do that. And so what we would do is we're taking this row 2 over here, and we're going to add 2 times of what we have in row 1. So for this first entry we would have 2, and then we want to add 2 times of 1. And so of course I will just write here 2 plus 2 times of 1. And so it should be 4, and that's going to become our new row 2, by the way. So it would become 4. Since we're only changing row 2, I'm just going to go ahead and write our row 1 that we had from before. And I'm sorry for this construction noise that's going on, but here we have, for the second entry, we're wanting to take 2 times of row 1, so we will have 2 times of 1 again. And we're wanting to add it to row 2, so we would want to add it to this negative 1. And that will give us 2 minus 1, which is 1, and that's what will go there. And then for the last one, we would take this number 2, and we will add to it 2 times of 1 again. So we basically have the same entry, 2 times of 1, and we're adding it to 2, so we will get 4 again. And so this one will become 4. And those are the elementary row operations that we can do, and this would be the proper notation for these. Notation for doing the row operations. So in the next video, we're going to get into actually what is going to be the process for solving these kinds of systems, and we will carry on with a very nice example where we're going to work through one of these whole ones. So thank you for sticking with this video, and I'll see you in the next one.